Our test file is now working, but there's definitely some improvements we can make. So the first thing I want to take a look at are the two queries that we wrote right here to first create a role and then create a schema associated with it. So you'll notice that we are doing some direct string interpolation here. And I said earlier on inside the course that this is definitely something we do not want to do because it leads to SQL injection exploits. Now in this case, there's zero chance of us having any kind of SQL injection stuff going on here because we're not working with any user supplied data whatsoever. In addition, I would never expect to see these lines of code executed against a development or production database. These are solely related to test databases. Nonetheless, I totally understand if you don't want to have code that looks like this inside your project. So let's try to refactor this stuff. Now, one way we could refactor this, or one way you would think we could refactor it, is to use that same kind of parameterized query approach, where we put in, say, role name, and then replace our usages of those variables with $1 and $2. You would think that would work. And based on the way that I am saying this, as you guess, yeah, it turns out it actually doesn't work at all. Why is that? Well, just a little note here from the Node Postgres documentation, which is the library we're actually using here to run these queries. So it turns out we can only use this parameterized approach when we are trying to put in literal values into a query. So whenever we're trying to substitute in, say, some kind of where clause or something like that. But we cannot use this approach for injecting parameters that are supposed to be identifiers. And an example of an identifier is something that's going to be, say, the name of a schema, a table, a column name, etc. So we cannot use this parameterized style if we are trying to designate the name of a schema, the name of a role, and so on. So in other words, we cannot use this approach to substitute in the name of our role right there, or the name of our schema. If we still want to do some kind of SQL injection prevention, we can instead use a package called pgformat, which is basically going to do a very similar thing to what you see here. So we already required in pgformat at the very top, so we're going to use that to handle this SQL injection stuff. Okay. So I'm going to find the pool.query. I'm going to just go ahead and delete that entire thing, and we'll replace it with our escaped version of the query. So we're going to put inside of here, format, I'm going to call it, we're going to provide a normal string. Inside there, we're going to put in create role, and then %i with login password %l. And notice that the I and the L are capital letters. Then after that query, we're going to put in a comma, and then we're going to list out the two values we want to have substituted in for that %i and that %l. So we want to substitute in role name and role name. The %i means that we want to substitute in something that's going to be an identifier. %l means we're going to substitute in something that's going to be a literal value. So this is how we use the format module to still do some kind of escaping when it involves a literal, or an identifier. Now let's do the same thing for creating the schema as well. So I'm going to delete the whole query and replace it with format. And then, what was this one? Create schema, %i, authorization, %i. And then role name and role name. Okay, so let's save that and go run our tests again. Okay, looks like our test is passing still. So, very good. But now we have definitely no chance whatsoever of any kind of SQL injection here. Again, wasn't really an issue to begin with, but now we're 100% sure of that. Okay, so good improvement. Quick pause right here. Couple more improvements in the next couple of videos.